In this question, which has to be done non-calculator, we have a definite integral. So we're going to need to do a few things here. We're going to need to find out what the antiderivative of this particular function is, and we'll evaluate that antiderivative at 1 minus the antiderivative evaluated at 0. To find the antiderivative, it's a little tricky, but it's definitely doable. What we need to do is we need to take the numerator and divide it by x squared plus 1. You could try to factor everything in the numerator, but you're just not going to be able to cancel anything out, and x squared plus 1 cannot be factored. So that's why I'm choosing polynomial long division. I'm going to show the long division here, and I want to put a filler in, which is 0x plus 1, because that term is missing right here. And I've got to divide the numerator by that denominator. You can do this using the area model, but unfortunately synthetic division won't work because you have a factor that is squared here, and you can't factor that x squared plus 1. To do this, we're going to think about the position in the just above the 2x to the third as being what times x squared is equal to 2x to the third. And of course, that's going to be 2x. Or you can think about it like 2x to the third divided by x squared. That's 2x. Then we're going to take that 2x and we're going to multiply it by each term on the left-hand side. So 2x times x squared is your 2x to the third. 2x times 0x is 0x squared. And you don't have to write the x squared there, but I like to write it just so I make sure that I'm adding and subtracting like terms. And then I have 2x times 1, which is positive 2x. In polynomial long division, I'll have to subtract those. And so if I subtract 2x to the third minus 2x to the third, I get 0. That's good. And then I have negative x squared minus or plus 0x squared, which is negative x squared. And then I'll have 2x minus 2x, which happens to be 0x. And then what I'll do is I'll bring my 2 down here. Haven't used that one yet. And I'll think about this expression now. I'm looking only at the leading terms. So I'm looking at my negative x squared and my x squared. And the question is, what times x squared is negative x squared? And the answer to that, of course, is negative 1. Then I'm going to distribute that across the entire expression I'm dividing by. So negative 1 times x squared is negative x squared. And then I'll have negative 1 times 0x, which is still 0x. And then negative 1 times 1 is negative 1. I have to subtract each one of those terms from the expression above it. So negative x squared plus x squared is 0x squared. That's good for us. And then we have 0 minus 0x, which is 0x. And then 2 minus negative 1 is positive 3. We don't have any more terms in the polynomial that we're dividing to bring down. And so this right here is going to be our remainder. So when we write the expression for the integrand using polynomial division, we wind up with this. We wind up with 2x minus 1 plus the remainder over the original divisor. Of course, this whole expression needs to have the differential on the right-hand side, dx. What we need to do now is figure out the antiderivative here. So we'll take that antiderivative and we'll evaluate it from 0 to 1. The antiderivative of 2x is x squared. The antiderivative of negative 1 is negative x, using your power rule in reverse. Next, we'll move on to the third term. And the third term right here looks to me kind of like one of those inverse trigonometric functions. So if you recall from your work with derivatives of inverse trigonometric functions, we can bring that 3 out to the front. And then we have the inverse of the tangent. And that's going to be just x. So if you move that 3 to the front, this will be like a 1 up here. And recall your derivative work. The derivative of the inverse tangent of x is 1 over x squared plus 1. We don't need the plus c here because we're going to be evaluating this from 0 to 1, and the c's will always cancel out. So let's see if we can figure out what this is. So let's do the antiderivative evaluated at the upper limit first. So that's 1 squared, or 1 minus 1, plus 3 times the inverse tangent of 1, minus, now we have to do the entire the entire antiderivative evaluated at 0, which is 0 squared minus 0 plus 3 times the inverse tangent of 0. So 1 minus 1 is 0, and then we have 3 times the inverse tangent of 1. Well, the inverse tangent of 1 is the angle that has a tangent of 1, which happens to be pi over 4. Pi over 4 is a 45-degree angle if you're thinking in terms of degrees, and each one of the legs of a 45, 45, 90 are the same. So when we divide opposite over adjacent, or y over x, we wind up with 1. For the next part, we have 0 squared minus 0, which is 0. And then we have to do 3 times the inverse tangent of 0. So we want the y over x on the unit circle to be 0. So the y has to be 0. And where the y is 0 is at a radian measure of 0. So the inverse tangent of 0 is also 0. Simplifying the left-hand term, we have 3 pi over 4. And then 3 times 0 is 0. So we wind up with our answer here, which happens to be choice B.